Hello everyone, and welcome back to CryptoCadet Academy. On today's lesson, we are going to continue our series about currency conversion. In the last video, we talked about rate conversion, or simple conversion as I like to call it. And basically what that is we want to purchase our token with a native token, say Ethereum in this example. It does a simple rate conversion and then it sends you that amount of tokens. No conversion really involved other than except for the rate. In this lesson, we're going to go over multi-currency exchanges and how that can kind of get a little tricky when it comes to the decimals. So in this lesson, we're going to talk first about ERC20 and the tricky part about that decimals function. Next, we're going to go over briefly Enums and how it could help kind of clean up your code if you're using multiple different currencies. Just as a reminder for everyone, if you are following along at home, you can get this smart contract and all the other smart contracts and source code at the CryptoCadet Academy GitHub. Without further ado, let's get started. So building on our last contract, the simple conversion contract from the first video, in this tutorial, we're going to be going over what I call multi-conversion. So we're literally just going to build on top of the last contract we did with a few tweaks. And what I mean by that is we want to do a couple things with this. Say we don't want the person to pay in Ethereum in this example. So the first thing that we can take away is this payable. And what you'll see here is then we have to do something about MSG.value, since you only use MSG.value for Ethereum or the native token. Next, what we have to do is we want to decide then what types of tokens we want to accept. So with that, let's talk a little bit about Enums. All Enums are the way I think of it is it's a naming convention to make your code look a little bit cleaner and more understandable. So if we said we wanted to do something like we want our contract to accept USDT, if we wanted to accept USDC, and we'll also do DAI. And I call it FUSDT, FUSDC, FDAI for a reason, and I'll get to that in a second. Basically, we're going to simulate how these tokens function because these are all ERC20s. We can technically make our own USDT and it's going to mimic the real USDT. So going forward, what we need to do then is we need to tell the contract what these contracts or what these tokens are like. So what we need to do is we need to set in our constructor that it should accept a few more addresses, just like this. Okay. And what we're doing here is now we want to set each of these as ERC20. And let's go ahead and copy that. FUSDC, FDAI. Oh, I'm getting a little bit ahead of myself. Sorry, we didn't declare our variables. So what we want to add, just like we did for token, we want to add these two. Okay, perfect. So now that we are not accepting Ethereum anymore, or our native token, hold on 1 second. What's the issue here? Oh, oops. There we go. So we need to do something with the parameters that are accepted by exchange. Now that we're not sending a value anymore, we now have to specify an amount, and we also will use a type, token type, which will represent the enum. Now, enum, as I mentioned before, is just kind of a way you can think about like a naming convention, just to make your code a little bit more understandable. What these actually represent, each name, they actually represent a number. So starting from 0, FUSDT would be 0, FUSDC would be 1, FDI would be 2. And what we're going to do with this instead is, when we put it in our code, technically you could use those numbers. But again, it's really just more about readability when it comes to enums and just making your code a little bit cleaner. So what do we do from here? We need to create a variable of type ERC20, IERC20. And what we're going to do, let's make some space. And we're going to say if the type equals token type FUSDT, selected token is going to be FUSDT. Else if type selected token equals FUSDC, and then else is just selected token equals FDI. Okay, so what next? Now, just as good practice, we don't want this function to run if the person doesn't have any money, or they don't have the correct balance of the token. So what we're going to want to do is we're going to want to check the balance of that particular token. It must be greater than the amount times the number of decimals. Insufficient balance. Okay. Oh, so we have an error. Now, what's this error all about? Member decimals not found or not visible after argument dependent lookup in contract IERC20. What you'll find is that I actually did this on purpose, not to trick you or anything, but I wanted to make a point. IERC20 is the interface that you'll often see with a lot of these contracts. If you check out IERC20, one thing that you'll notice is that, let's go through the functions that belong to this interface. So we see there's balance of, we tried balance of and it worked fine. Total supply works fine. Transfer works fine. Allowance works fine. Approval, transfer from. It has all of these functions to it, but notice what's missing. Right, there's no decimals function for this interface. What you need to remember is that if you don't have the proper interface, what an interface is doing is it is just saying that if you call this function in this interface, it's just saying that the contract that I'm calling on has this function. However, if your interface that you're using doesn't have this function available to it, it can't call it. So it has nothing to do with the contract you're calling. It has everything to do with the contract that you're writing. For this reason, a lot of these contracts will have stuff like IERC20 metadata. And as you can see, these are some of my missing functions, right? Name, symbol, decimals. Just a little heads up. It's kind of a quick little gotcha that we need to fix. And we need to fix it for all of the tokens that we're using, because we're going to want to call in these decimals. So instead of calling it IERC20, it's actually IERC metadata. And then when we change this, you see that we have to change all that. And IERC20 metadata, if you noticed before, it's in IERC20, so it inherits everything that you would get from IERC20. So that's kind of how that works. And let's change this. And that one. And then we also have to change this one. And see, so you notice the error now goes away. So another thing to mention, what does this mean here, this selected token dot decimals? So one thing that you're going to see in a minute when we deploy this thing is that all of these fake tokens that we're using for this, they're gonna have different decimals. Now, for sake of the tutorial, we're going to make them different than what they are normal. Like, for example, USDT and USDC are both 6. DAI is 18. So it's going to be kind of boring if we use like 18 for DAI. So what we're going to do is we're going to change up those decimals purposefully, so you can see it represented in this contract, that instead of doing something like hard coding, this would be 6 instead of selected token dot decimals. That's hard coding values is pretty much a no-no when it comes to making clean, reusable, flexible code. So this is why we want to call on that function, and for that reason we need to cast each of these addresses to make sure that they have the correct interface. So with that said and out of the way, let's continue. So what we want to do next, let's go ahead and get rid of this amount. And let's say the total we have now is going to be the amount times the rate times the decimals And another quick distinction here is, if you are following along since the simple conversion contract, you'll notice a key difference, and it's the reason why I wanted to underscore amount, so your eyes wouldn't just kind of pass over it when you do it. We are purposefully making this amount without decimals, and you'll see what I mean in a second. If we were to add decimals, we would have to do another conversion that might be a little bit trickier. So what we want to do is we want to just take the number without decimals and then make our conversions from that. And you'll see what I mean in a second, and why, in my opinion, especially if you were linking this to a front end, it's just going to be a lot cleaner and easier and more user friendly. So there's that. Now there are a couple things that we need to change from here. We no longer need this payable owner wallet transfer anymore. What we need to do instead is take this selected token and then we're going to do a transfer from. And now you're transferring from the MSG.sender to the owner wallet the amount with the correct decimals. So now what does that person get back? Well, we have it down here. This is the one thing that we don't necessarily need to change because you're still using that transfer from after approving from the previous step. Another thing that I want to add, just to kind of drive home the point, it's not super necessary because we know what it does, but let's just go ahead and check our token type just so you see how it's written. So if I wanted to check the enum just to make sure it's 012 like it's supposed to be, this is how it looks. So the function is going to just return, and this is how you would return like a group of variables or a group of values. Okay, and that's all good. So be careful with this transfer from function. I'll show you why in a second. It's going to be a little bit different than what we did for our token that we launched, the Multiconversion token. So let's go ahead and do a couple things first before we deploy this thing. What we need to do is, remember, in our constructor we're taking 4 values. We're taking the owner wallet, we're taking FUSDT, FUSDC, FDAI, and we're saying set all of these addresses from the get-go. So what I've done, and I've also added this to our GitHub repository, is I just went ahead and made a few fake contracts. And one thing that you'll see, let's check out FUSDC, is with these ERC20 contracts, one thing that you'll notice is if you look at, let's go ahead and find the decimals. For these ERC20 tokens, the function is set to send 18 or return 18 by default, because way is 18 decimals for Ethereum. It's natural, or like the normal number is 18 decimals. What you'll see here in terms of naming conventions, virtual just is, it's kind of just syntax that's added to signal to you that, hey, this is okay to override. This is meant for you to override, right? So what you would do is, if you wanted to have different decimals, you would just override it like this. So now when I deploy this thing, and I can show you, I'll deploy this thing and I want it to have 9 decimals. Here. For initial supply, let's say I want to do something like 1 billion. So I'll do, and GUE is 9 decimals, so that's a nice little cheat. Add it and deploy it. Now with fake USDT-DC, if I go to check decimals now, it's 9, not 18, right? So that's what that means. So we can go ahead and do this too for fake DAI. Fake DAI, I changed it to 12. Let's add 3 zeros to it. what's the last one? Fake USDT. Fake USDT has 6 decimals. Okay, so what we're going to do now is we're going to take all of those What we're going to do now is we're going to take all of those, and when we deploy, we're going to add our owner wallet, FUSDT, fake DAI, fake USDT. Okay, perfect. Transact, and we're good to go. Look at that. Okay, now for the interesting part. What you need to do is you're going to use this exchange function with another wallet, but there is an additional step that you need, and it's called the approval step. What we need to do is, let's say, for example, we want to start with fake USDC. What we need to do is we need to copy this address, and we need to approve the amount that the contract can spend. Here's what I mean by that. Let's go ahead and let's change to the second address. And if you noticed, when I was deploying these fake currencies, I sent half of the supply to the second wallet. So don't let that confuse you when I start kind of running through this. It has a balance of all 3 of these tokens to spend. But what we need to do is we need to authorize this multi-conversion contract to spend our currency. So we'll put in the address of the multi-conversion contract, and we need the amount. So let's do $50, and we know that USDC is 9 decimals. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Go ahead and approve that. And that's all we need to do. Now what we want to do is, so FUSDC, we want to get $50. Remember, we're not using decimals for the amount, which if you're doing this from a front end, that's going to make a lot more sense. You want people to just be able to input what's intuitive to them. $50 is intuitive. 50 plus however many decimals, you're basically asking for some user error there, right? So that's why we did it this way. Just put in 50, call it good, and then our contract will do the math for you. So type, what's the type? If we go back to our enum, you know FUSDT is 0, FUSDC is 1, FDAI is 2. So we want to put in 1. Now, if everything works fine, let's just go ahead and make sure. So let's copy and paste the balance. Balance should be 0 for multi-conversion for this second wallet, right? If the rate is correct, what it should do is it should take that 50 times 100 and give us 5,000 of the multi-conversion ERC20 token. So it's going to convert all of that based on this. So let's hit it and let's see. Okay, so we see that the transaction was good. Now let's check the balance. So this big old number, let's go ahead and just convert it. Put it in way. And there we go. So we got 5,000. That is the correct conversion. Just so we know we've got it, let's go ahead and try another one. Let's go ahead and do FUSDT this time. So FUSDT is 6 decimals. So what we need to do again is we need to take our multi-conversion contract, Go to approve, put in the address, the amount this time, let's make it $70. $70 and 6 decimals. So 1, 2, 3, 4, 5, 6. Approve it. Let's go down to exchange, 70, and this time type is 0. Transact. Check our balance. Okay. And we can check it again to see if it should be what? 5,000 plus 7,000 should be 12,000. And look at that. Perfect. So what you guys have here is basically a multi-currency exchange platform that you don't have to worry about decimals going wrong. You don't have to worry about any of that. You just have to send your money and it sends you the proper amount of tokens. So that will be it for me. Please give a like and subscribe, and I'll see you on the next one. Thanks.